What's up, brilliant minds? I'm going to teach you how to solve a system of equations algebraically using two different methods, the substitution method as well as the elimination method. So let's first talk about what is solving a system all about. We're trying to find an x value and a y value, often given as a coordinate. So once we find an x value and a y value that would work in both of the equations, that's what a system is, more than one equation. There's got to be a ton of combinations out there that work for one of them, right? I could put a certain number in for x, that's going to spit out a certain number for y. But if I change that number for x to a different number, it's going to spit out a different y value, okay? So if you're only dealing with one equation, tons and tons of combinations work. But if you have two equations, there's really only going to be one combo of numbers, an x and a y, that when plugged in here and here, makes this statement true, and then when plugged in here and here, also makes this equation true. So how do we find out what those two numbers are? There's only one combination in the entire world. Well, we can use the substitution method or the elimination method. I'm going to talk to you about why the substitution method is good over here, why the elimination method would probably be a better choice for this system over here. If you look, this one's written out very similar, standard form and standard form. Over here we got something in slope-intercept form and in standard form. So I would go with the substitution method here, and let's talk about why. Okay, so let's figure out what those two numbers are that make this and this true. Well, when we're in slope-intercept form, something special, y is isolated. It's all by itself. Anytime you have an isolated variable in a system, what you're going to probably have on the other side is an entire expression, okay? So what I tell my students to do is just take their pencil and put a box around what is equal to the isolated variable. So if you look right here, negative 2x minus 9 is the exact same thing as a y because they're equal. That's what equal means. This and this are the same. So if you see a y down here, we no longer need to show it as a y. We could say negative 5 times, because when you have negative 5 attached to y, the coefficient attached to a variable, that's multiplication. So what we're going to do is we're going to say we want to take negative 5 and multiply it by what we know y to be equal to. So anytime you have an isolated variable, box around it, take the information in the box, and put it where the y is on the other problem. If this was x equals, and there was an expression over here, this information would go where the x is. But because this is equal to y, we're going to put it right here next to the negative 5. So I take negative 2x, negative 2x minus 9, put that right there in the parentheses, and then I bring my equal sign down, my negative 19 down, and don't forget about this 6x that we haven't brought down yet. All right, now if you look, what we did is we took this expression, which only had an x in it, replaced it, we substituted it out with the y, and now I have an equation with no more y's, okay? The problem was we have an x and a y. Now that we've written it out, subbing y out with an expression, we only have x's. And when you only have one variable, we can solve these bad boys. Negative 5 times negative 2x. A negative times a negative makes a positive. Negative times a negative also makes a positive. Don't forget your x. Negative 5 times negative 9, positive 45, equals negative 19. Don't forget about your 6x right here. Combine your like terms. 6x and 10x come together and make 16x. 45 comes down. It's equal to negative 19. We're in a two-step equation. We're going to take 45 away. Take 45 away from negative 19. We're already at negative 19, going further down. That's going to take us all the way to negative 64 is equal to 16x. Divide, x is equal to negative 4. Okay, I got one of my numbers. Remember, we're looking for an x and a y. So right now I could say one of my numbers is negative 4. That would be the x value. But how do I figure out the y value? Well, the good news is we've got equations up here, this equation or this equation that we could place negative 4 in for x. So I just take negative 4 as my value. I'm going to put it right there where the x is in this top equation. You could also use the bottom equation. You'll get the exact same result. Let's use the top for now. Y equals negative 2x. Well, that x is going to show us a negative 4 now. So y equals negative 2 times negative 4 minus 9. Once I clean all this up and have it simplified, I'll know exactly what number y needs to be. Negative 2 times negative 4 gives me a positive 8. Minus 9. 8 minus 9 is negative 1. Now I've got my x and my y. My coordinate would be negative 4, negative 1. When you finish these, I like to tell my students, take the two values, plug them into both equations, and make sure they come out to be true. We already know that they're going to work on this one, because that's how we got it. Now take a negative 1 and a negative 4, put them in for the x and the y. So negative 4 for x. That's 6 times negative 4. Well, 6 times negative 4, negative 24. Negative 5 times y, y being negative 1. A negative 5 times a negative 1 would give me a positive 5. And look at what we get. Negative 24 plus 5 makes negative 19, just like it should. We've checked our answer. It works in both equations. Let's move on to the next method. Okay, the elimination method, this is something you're going to use not when you have an isolated variable already. You see an isolated variable like y equals, boom, right away, put your box around, substitute the expression in for the variable. Okay. Over here, however, x is not isolated on either of the equations, nor is y. So what I'm going to do is I'm going to use the elimination method. We need to eliminate an x or eliminate a y. The way we do that is we try and match these parts up. So I want to make a 10 and a 10, or a 3 and a 3, or a 6 and a 6, or a 5 and a 5. Okay? Well, I'm looking right here at this. This part is definitely standing out to me. I could just take this entire equation, multiply it by 2, and what that's going to give me is a match here. Because 2 times negative 5 is going to give me negative 10. So all I'm doing is distributing 2 to each one of those terms. 2 times negative 5x would make negative 10x. 2 times negative 6 would make negative 12. 2 times a 23 would make a 46. And now I have equations that have a match, a duplicate. Okay, so all I did there was multiply everything times 5, or excuse me, by 2, so that this term matched up with that term. Now what we can do is eliminate. We can eliminate x's off the table, get them out of there. Just want y's so we can solve. We can't solve with two variables. There's too many possibilities. But if we can get one variable, we can solve for it. So what operation, what would I have to do with these two values to make them cancel each other? Will we add them together or subtract them? Let's think. Negative 10 plus a negative 10 would take me way down to negative 20. No, that doesn't cancel. I need to make a 0. Negative 10 minus a negative 10, no different than adding. So negative 10 plus 10 would cancel. We've eliminated the x's. They are gone. They are off the table. Now we're just going to subtract straight down. 3 minus negative 12 minus a negative is really adding. So 3 plus 12 makes 15 with a y. 1 minus 46 takes me way back to negative 45. I've got a one-step equation. We can divide by 15. Cancels a 15. Divide by 15. Don't forget that a negative divided by a positive will always equal a negative. And in this case, it's going to be 3. I've got one of my variables. Now this last step is no different than what we do over here in the substitution method. Once you figure out one of the variables, take that value. It's worth a y. I can put it right there or right there so I can solve for x. Let's use the top equation just because it's smaller numbers. I don't want to have to deal with 46 and negative 12. So let's just use this top equation. Negative 10x plus 3y equals 1. But y is no different than a negative 3. So I'm just going to erase that y. Put a negative 3 in its place. Now I can solve because I only have one variable. 3 times negative 3 is negative 9. 10x comes down. Excuse me, negative 10x comes down. It's equal to 1. I'm in a two-step equation. We're going to add 9. Cancels, add 9. Negative 10x equals 10. Divide by negative 10. Divide by negative 10. X is equal to a positive divided by a negative, which is a negative, and 10 divided by 10 is 1. I've got my x, I got my y. I know my solution is now going to be -1, -3. If I want to check and make sure that this is correct, all I got to do is put a -1 in for the x, -3 in for the y, and hope that this comes out to 1. Put a -1 in for the x, put a -3 in for the y, hope that this comes out to 46. All right, so that should be all you need in order to start solving these systems algebraically. You can also solve them through graphing, but we want to be able to move terms around, replace, substitute, solve for variables. These are all those basics of algebra that we need to know. Hopefully this makes sense. Study hard and good luck on your upcoming test.